Congratulations, Math 8 kids. We made it to the end of our first topic, and you should have your book open to page 74. I'm going to do a quick review of each thing, and then we're going to go over the problems in the book. So if you want to listen to this review and then do the problems that go with it, or if you already did the problems, just listen to this quick review. The first thing we started our unit with is talking about rational and irrational numbers. The way that I talked about it with my class is that rational starts with ratio. Ratio is just another name for fraction. So anything that can be written as a fraction, as long as the denominator is not 0, is going to be rational. And then I also remember the R and the T. The R is for repeats, so if you have a repeating decimal, like 0.2 repeating, that can be written as a fraction, that's 2/9. So here's our fraction, so we know any repeating decimal is a rational number. And then the T is for terminates, which means stops. So when you get your quiz or test, if you think you need, something to look back to help you with this, just write the word rational, or if it's already written on the paper, just underline ratio and circle the R and the T, and if you want to write this down, that's fine. You can write, as soon as you get your test, you can write anything else on your test that you want that will help you as you're doing those problems. And then irrational is basically the opposite of any of these. So it cannot be written as a fraction. There are no repeating set of digits, and it does not terminate. The ones that you need to be careful about is that they're going to give you some square roots. The square root of a perfect square is going to be rational. Any other square roots are going to be irrational. So let's look at our problems for this. So this is on page 74. So if you have not done these, please do that. And then when you're done, check your answers. So you might need to pause the video. Alright, so the ones that are, it says determine which are irrational. And sometimes I just like to put, I'm going to put rational or irrational. So I know this is rational because it's a perfect square, because 6 squared is 36. Okay, this is not a perfect square, so that is going to be irrational. This one you can see it's doing 2, 3, 2, 3, 2, 3. It's repeating a set of digits. So repeating is rational, so I don't want to check that one. This one has a repeating pattern, but it's not a repeating set of digits, so this one is going to be irrational. This one has a repeating set of digits, so that is going to be rational, so I don't want that. And then pi, that keeps going forever. It's non-terminating, so that is going to be irrational. A couple other ones, 0, obviously that terminates. I wish they had a couple other examples, like 3.4, 7, 8, 9, 6, 2, 1. Okay, as long as the number stops, this would be rational. As soon as I put a dot, 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 if it keeps going and I don't see like repeating set of digits, that would be irrational. Okay, so this one right here obviously is going to be rational, and it's because it has a repeating set of digits. And for this one, that would be 25 over 99. So there is a little trick for those, whatever numbers repeat, you put that over the same number of 9s. That was from lesson 1.1, which we skipped over. Alright, then we need to put our numbers, our squares, in find the perfect squares. So for this, you want to make sure that you know your perfect squares. A perfect square is a square of an integer. For example, 2, that's an integer. When I square it, 2 squared is 4. Okay, 3 squared is 9. So you need to be able to recognize these perfect squares. So when it says 89, okay, I need to think of what are the perfect squares closest to 89. 89 would be right here. It's between the square root of 81 and 100. So it's between the perfect squares of 89 and 100, so therefore we know it's going to be between 9 and 10. And you can use the perfect squares. Since we are allowing you to use a calculator, if you want to double check, just in your calculator do the square root of 89 and hit equals, and I get 9.4, so obviously that's between 9 and 10. Okay, then it's giving me some numbers, and I need to basically put these in order, and if I needed to put them on a number line, I could do that as well. So you want to find the decimal equivalent for each one. So the only one I probably need a calculator for is the square root of 8, which I know from my perfect squares it's a little less than 9, and 3 squared is 9, so I know it needs to be a little less than 3. So if I put 3 here, I know my square root of 8, is going to be a little less than 3. And this doesn't need to be like super exact here, but we do want to make sure we're getting them in the right order. So if I have 2 here, okay, 2 and 1/4, you should recognize 1/4, a fourth of $1, 25 cents. So that's 0.25. So that one's going to go next. Okay, and then I have a 2.3 and a 2.5. So obviously 2.3 is going to go next, and then 2.5. If you did want to double check the square root of 8, you could do that on a calculator and just make sure that that's bigger than 2.5. Alright, the next one, we are looking at our perfect squares and perfect cubes. So we already talked about the perfect squares. A perfect cube is a number whose cube, the cube is a integer. So 1 times 1 times 1 is 1. 2 cubed, okay, 2 is an integer. When you cube it, you get 8. So 8 is the perfect cube. 27, 64. These are, I think, the only ones I have memorized. Sometimes I recognize them, but if you're not sure on these, then you want to make sure that you use a calculator. So hopefully you should know by now how to do the cube root of these numbers on a calculator. So for 27, okay, I know that's not a square, so I'm going to just check if it's a cube. I know, but we're going to just double check. So 3, and then I want to use my second button with the x cubed, and then 27, and that equals 3. So yep, and I saw 27 right here too. So this one is a cube. And again, on your test, if you want to write these out, okay, if that helps you out, you can do that. 100, hopefully you recognize that that's a perfect square. If you aren't sure it's a cube, we can double check. So 3, second, and then I use my x square root button, and then 100, and hit equals. Okay, that is not equaling an integer, a whole number. So we know that 100 is not a perfect cube. Okay, 64. So you see here's 64 here, here's my 64 here. So this one is going to be both. And then 24. That one is going to be neither. And again, by the time you're checking these, you should already have them done. I forgot to remind you of that, but please make sure that you have them done before you are, so that you can check your answers. Alright, the next one says a gift box is a cube. So there's our hint. It's a cube, and the volume is 512. We need to find the length of each edge of the box. So it's a cube, so to find the length of one edge, we need to do the cube root. So I'm going to do the cube root of 512, and that equals 8. And then you would say inches for your units. Alright, so we're going to turn to page 76. Again, please make sure you have these done before you're going through and checking your answers. This is similar to what we did before with the cubes and the squares, but this time they're giving us an equation. An equation means it has an equal sign. So we're getting into solving for x. When you solve for x, you need to do the inverse operation. So the inverse operation, if you remember, so if we're adding, the inverse of that is subtract. If we're multiplying, the inverse is divide. If you square a number, the inverse is to do the square root. And if you cube a number, the inverse operation is to do the cube root. So it's kind of the same thing that we did on that cube problem on the previous page. So it's saying some number times itself 3 times is 64. We need to get rid of the cube, so we need to do the cube root to both sides. Okay, these are going to cancel out, and we do the cube root of 64, which we should get 4. 4 times 4 times 4 is 64. Okay, Next one is a square, so we need to do the square root to both sides. Square root, square root. Now, this one we need to be careful about, and how I taught my class, we tried to remember, is we talked about how you have a square and a square root, and this lightning bolt comes and wipes out these, cancels these out, and because it's lightning and because it's the number 2, which is like an even number, it's splitting evenly in half, and it leaves us with a positive and negative charge. So we kind of did that little story to help remind us that when you do the square root of a square, okay, when we're solving for x, you need to have plus or minus, and then the square root of 49 is 7. So what that's saying, because we're solving for x, so what that means is that when we put 7 in for x, so 7 squared equals 49, because 7 times 7 is 49. But we're also saying that negative 7 squared equals 49. So negative 7 is a solution also, because negative 7 times negative 7 is a positive 49, because a negative times a negative is positive. So you only do that with even exponents, because the even exponents split evenly in half, leaving that positive negative. If that story helps you, hopefully that will help you remember it. Okay, this one, we're doing the cube root to both sides again. This one is not, so 25 is not a perfect cube. So we actually get to leave our answer just the cube root of 25, and we're done. If you want to, if it says to give an approximation, then you would use a calculator and round to the nearest tenth. So please make sure that you pay attention to the directions. Okay, this one is a square, so we're going to do the square root of both sides. This is not a perfect square, so we can leave our answer 125, the square root of 125, or if it says to give a decimal approximation, then you would do it on your calculator and round to the nearest tenth. Alright, this is similar to the question before. We have a cube, the volume is 216. So the first step that we need to do is find the length of one side, which 216 is one that I have memorized, I remember, so that's 6. So one side is 6. But it's asking for the face. So again, make sure that you guys are reading the directions carefully. We had one like this on our mid-topic quiz. So the area of one side, we have to do 6 times 6 yet, which is 36. And that would be square inches, because it's two-dimensional. Then we got into our rules of exponents, and that was for 1, 7, and 1, 6. So I will quickly go through those with you. The thing I remember about these is, if you see here, this only works with multiplication and division. So if you ever had an addition sign here or subtraction, the exponent rules don't work. For this one, you can see the base is staying the same. So what stays the same, stays the same. And then we are adding the exponents, 9. And if you think about it, it's like we have 5 x's here, we have 4 x's here, it's a total of 9 x's. For this one, the exponent is staying the same, so we're going to keep the exponent the same, and we multiply our bases. So that's 6 to the 4th. When you divide, that's the opposite. So now I have, and they did the picture like this, you have 6 x's on the top, and you have 4 x's on the bottom, because you can use that for divide, and these are all canceling out, so we're left with 2 x's, so that's x squared. So you subtract the exponents. So the base stays the same, 6 minus 4 is 2. This time I switched it around. Base is going to stay the same. 4 minus 6 is a negative 2. You can't leave a negative exponent. So you need to use our other rule, which you need to do the reciprocal, or put this under 1. So you drop this whole thing in the bottom, change the exponent to positive, and put 1 on the top. So to make a negative exponent positive, you do the reciprocal, okay, or drop it in the bottom, 1. I have a couple other examples down here. 5 to the negative 2. So this whole thing, if you have a negative exponent, put the base and the exponent in the bottom, make the exponent positive, and 1. Okay, I have one like this. So again, this one, I can just do the reciprocal. Flip this around, okay. Reciprocal means change the numerator and denominator. So I'm going to put 3 over 1 and then this becomes a positive exponent too. Now, we don't really need the 1 here because 1 times 1 is going to be 1. That's not going to change. So the best way to write this answer would just be 3 squared. Okay, this one, if the negative is on the bottom, then you just flip it and put it on the top, and then the exponent becomes positive over 1. So again, we would just write this 6 squared because we don't need the 1. Okay, we talked about anything to the 0 power is going to be 1. So any crazy number they give you to the 0 power is going to be 1. And then this is power to a power to a power, so I have x to the third times x to the third, okay, because I'm squaring it, so I have that 2 times. Using the rule up here, we add our exponents, x to the 6th. So for power to a power rule is you multiply the exponents. So again, make sure you have the pages done in the book, and I'm going to start the next movie and we'll start going over those problems.